Okay, our last section of Chapter 8 starts off with rational equations. We're doing the equations today, we'll do the inequalities in the next video. So a rational equation, this definition should make total sense, it's an equation that contains one or more rational expressions. Okay, an equation that contains one or more rational expressions. So if you look down below, example 1 provides us with some great examples. Remember, rational expression is basically a very fancy word for a fraction. So you can see parts A and B are just kind of filled with fractions. So I'm going to give you guys a checklist, kind of like a how-to, like a step-by-step. And then we're going to follow that step-by-step for both of these examples here. Okay, so we've got 3 steps. First step is to multiply both sides of the equation by the LCD. Okay, so both sides of the equation, because remember, whatever you do to the left of an equation, you have to do to the right. And I guess kind of as part of step 1, you need to find the LCD. Step 2 is we are going to reduce the common factors, which will make sense once we're actually looking at an example. And then step 3, it'll look just like a normal equation, and then you're going to solve. Solve for x, solve for a, whatever the variable is. Okay, so these are your steps. You're going to follow this step-by-step process for any of these equations that you're going to do. And then, very important to check your solution. I'm going to walk you guys through, remind you of that solution check on the calculator. All right, so let's look at all of these denominators here. If there's anything that can factor down, you factor it down. But look at the variables compared to the numbers. So this one, for instance, my LCD, it needs to have an x plus 3. I know that for sure, but I know it's also going to have a number. So then you look to see what's common between the 2 and the 10. What's the least common multiple of 2 and 10? Or, you know, what does 2 go into that 10 also goes into? And that would be a 10. Okay, so we found the LCD. All 3 of these things right here go into this LCD, but it's not too big, which makes it the least common denominator. Then I'm going to multiply both sides. Okay, so both sides of the equation, the left-hand side, the right-hand side, and what I end up doing is I distribute it. So that means every single piece that I see right here is going to get multiplied by my LCD. Okay, so I'm going to write my equation, and I'm going to kind of spread it out so I have room for my LCD. All right. This should probably be over here. All right, sorry, ignore that. So I'm going to multiply everything by the LCD. So this first term, I'm going to multiply by the LCD. Then the second term, I'm going to multiply by the LCD. Oops, I don't know why that 2 is there. It's not a thing. Okay, so I multiplied all of my terms. I basically took this whole side and multiplied it by the LCD, which means I distribute. That's step 1. I don't really do anything beyond just writing it down, because then step 2 is to reduce the common factors. So as you look term by term, here I have an x plus 3 over an x plus 3, and so they cancel. And then I'm left with 10 times 2, which is just 20. Plus, then if you look at the next piece, 10 over 2 will reduce down to 5. And then I have a 5 times an x plus 3 times a 3. So basically, 5 times 3 is 15. Then distribute that. So I have 15x plus 45. So again, what I did there, I multiplied 5 times 3 first, and I got 15. Then I distributed that 15 to the x plus 3. Equals, and then over here, the 10s will cancel. And I just distribute 19 to the x plus 3. So I have 19x, and then 3 times 19 is 57. Okay, from that point, I am now into step 3 where I solve. So I combine up like terms, get my variables alone. So I have 15x, and then I combine the 20 and the 45 to get 65 equals this. Okay, then let's subtract the 15x from both sides. And at the same time, I'll subtract the 57. So these cancel. I'm left with 8 equals, and then these cancel, I'm left with 4x. So last little step, when I divide both sides by 4, I end up with 2. Okay, we are not necessarily going to box that up because we need to check that that's actually our answer. So remember, you're going to go just right into a calculator page. This is how you do that check. And you take your answer of 2 and you store it in as x. And then you type in your equation. So 2 over x plus 3 plus 3 over 2. We want to know if that equals 19 over 10. And we get true. Okay, so that is our answer. So we're going to box it up and call it a day. Next, we're going to do the exact same thing down here. You find the LCD first. So you might as well start with the number part since that's the part I wrote first here. So between 12 and 48, we want a number that's a multiple of 12 and a multiple of 48. Well, 48 already is a multiple of 12, so that means that 12 goes into 48, 48 of course goes into 48, and then we need the x minus 4. So same exact thing I did up above. So I'm going to take my expression right here, write it out, spread it out a little bit because the next thing that's coming is my LCD. Okay, so this is the original equation that I had right here. Step 1 is to multiply both sides by the LCD. And I'm technically multiplying by the numerator. Just keep that in mind. Okay, so now step 2, I'm going to reduce common factors. So 48 over 12 reduces down to 4. X minus 4 over x minus 4, those will cancel. And then 48 over 48, those will cancel as well. So I have 4 times 7, that's 28. And then I'm going to distribute a 28 to the x minus 4. Okay, so 28 times x, and then 28 times 4 is 112. Plus, and then I have 48 times 9, which is a lovely 432, equals, and then here I distribute the 55, so 55 times x, and then minus 4 times 55 is 220. So for some weird reason, you know, we've got some really big numbers here. So let's combine up our like terms. So here I have 28x, and then I need to combine up a positive 432 with a negative 112, and I get 320. And then I can do what I did on that last problem, whoops, where I start to, you know, I'll subtract this 28 from both sides, and then I can add this 220 to both sides. Okay, so these cancel, and I'm left with 540 equals, and then these cancel, and then I am left with 55 minus 28, which is 27, x. And then as a last step, I'm going to divide both sides by 27. And so 540 divided by 27 leaves me with 20. Okay, so that is hopefully my answer. Remember, we're just going to double check. Okay, so I take 20 and I store that in. Whoops, store that in as x. I'm going to type in this new equation. So I type in 7 over 12 plus 9 over x minus 4. We want to know if it equals 55 over 48. And it does. Okay, so those are your first 2 examples there. The same step-by-step process. And now I'm going to remind you of why we are checking our answers. And that is because we may end up with extraneous solutions here. We've seen extraneous solutions many times. It is possible that they could come up with rational functions. And that's because I do have a restricted domain. I have certain values that I'm not allowed to plug in. So if my answer turns out to be one of those values that I can't plug in, it would be extraneous. Okay, so watch and see what happens. So we start by trying to find the LCD. So here, let's first factor this down. That last denominator is the difference of squares. So z squared minus 1, we can factor it to z plus 1, z minus 1. So now here are my denominators. I have a z plus 1, a z minus 1, a z plus 1, a z minus 1. So my LCD, remember you take everything you need without taking any extras. For this one, I need to make sure I have a z plus 1. For this one, I need to make sure I have a z minus 1. And for this one, I need to make sure I have a z plus 1 and a z minus 1. But if you look, I already do. So I don't need to add anything extra. And I follow the same steps. Step 1 is still multiply both sides by the LCD. So I'm just going to leave myself a little space so I can do the exact same thing. I'm going to write my factored version there, the z plus 1, z minus 1. So now when I multiply both sides of the equation, remember I distribute my LCD to these two pieces. So it's...
May I have your attention? Lauren Davidson. If you're in the building, could you please come to room 107? Lauren Davidson.
It's a special cameo by Mrs. Tarr. You're welcome for that. We're going to multiply both sides by our LCD. Z plus 1, z minus 1, which means we end up distributing that LCD to every single term. Okay, and then step 2 is we reduce the common factors. So I have a common z plus 1 that I can cancel. Here I have a common z minus 1 that I can cancel. And here I can actually cancel the whole darn thing. All right, so let's look closely and see what we have. Here I have a 2 times a z minus 1, so I can distribute like that. And then here, very, very, very careful, I have a negative out front, so I might as well treat it like a negative 1 times the z plus 1. So that gives me a negative z and then minus 1. Careful with that negative. Equals, then all I have left on the right-hand side is a negative 2. Literally everything else is canceled. Okay, so start to combine like terms. So 2z minus z, I have just a z. Negative 2 and a negative 1 is negative 3 equals negative 2. So I am going to add 3 to both sides. Z equals 1. So before we box that up, look at the original equation. If I try to plug a 1 into this denominator right here, I would have 1 minus 1, which would be 0, and that's undefined. So that's the exact scenario I was talking about. That makes this solution extraneous. Okay, let's look at another one. We're going to factor down these denominators, so I'm actually going to rewrite the entire thing. So 7n over, this denominator I can factor to GCF. Do not forget about the GCF. Happens with a lot of factoring. So there's a 3, can factor that out, and I'm left with an n plus 1. Minus, for this term I have a 5 over, here I can factor out a 4, and I'm left with an n minus 1, equals 3n, and then over, here I can factor out a 2. And then I have an n plus 1 in parentheses. So once it's factored, you can see that I actually have some common stuff here, and so the LCD will be a little easier to find. So let's start with the number. So among the 3, the 4, and the 2, we want the LCD, the smallest thing that's a multiple of 3, and a multiple of 4, and a multiple of 2, and that would be 12. And then for the variable part, I need to make sure I have all my pieces. So I need an n plus 1, so I'm going to throw 1 in. I need an n minus 1, so I'm going to throw 1 in. And I need an n plus 1, but I already have 1, and that's good enough. Okay, so I found my LCD. First thing I do is I'm going to multiply both sides of the equation by the LCD. So I multiply this side, then I distribute it, then I multiply this side. I'm going to leave it in factored form. You always, always want to leave in factored form because it's going to make it a lot easier to see what cancels and what doesn't. Okay, so I'm going to distribute my LCD. So 12 and then n plus 1 and minus 1. Squeeze that in there. Okay, step 2, reduce down my common factors. So I have an n plus 1 that will cancel, and then 12 over 3 reduces to 4. Here I have an n minus 1 that will cancel, and then 12 over 4 reduces down to 3. N plus 1 will cancel, and then 12 over 2 reduces down to 6. So see, if we didn't pick a big enough LCD, the denominators wouldn't all cancel out. That's kind of my point here, is to get the denominators to cancel out, and without the right LCD, that won't happen. Okay, so let's look at everything I have. Here, I need to look very carefully. So I have a 7n times 4. I'm going to do a little bit at a time. That's a 28n, and then times an n minus 1. Minus, I messed this sign up here, minus 3 times 5 is 15, and then times an n plus 1. We've got one of those left over as well. Equals, and then we have 6 times a 3n, that's 18n, and then times an n minus 1. This one, just the equation itself is going to be a little bit more complicated. So I'm going to distribute the 28n. So I will have 28n squared and then minus 28n. Then here, be very careful. Make sure you distribute a negative 15. So I have negative 15n minus 15 equals, and over on the other side, I'm going to distribute an 18n. So I have 18n squared minus 18n. And so I'm going to go ahead and combine up all my like terms. Get them all on one side. I have a quadratic. Remember, anytime you have a quadratic, you're going to be doing some factoring. So we're going to gather everything over on the left-hand side. So I can combine these two up. I have a 28n squared. These two, I combine them up. I'm going to have minus, I don't trust myself to do mental math right now for some reason, 43. And then minus 15. And then I'm going to take these two terms and either add or subtract. So minus an 18n squared, so it'll cancel over here, and then plus 18n, so it'll cancel here. And then all I have is just a 0. Okay, running short on space, I'm sorry. So here we get a 10n squared, and then if I add 18 to that, I am going to get minus 25n, and then minus 15 equals 0. So I'm going to factor. I'm going to keep going here. So I'm sorry, this is taking up more room than anticipated. Factor out of 5. So basically what you're going to do is divide the entire equation by 5. So here I get a 2n squared minus 5n minus 3. So that makes everything a little easier to work with. Now I'm going to factor. So I have to start with a 2n and an n. We do that whenever we don't just have a nice easy n squared here or an x squared or whatever. Then we're trying to multiply to negative 3. And add up to a negative 5 in the middle. So if I put my negative 3 here, this will give me a negative 6. So then I put the plus 1 here, and that gives me a positive in the middle. So you can always refoil. I promise you'll get the right thing. So last thing I'm going to do is take this and set it equal to 0, and then take this and set it equal to 0. So here I can start by subtracting 1. And then dividing both sides by 2. That's one of my answers. And then here I just add 3 to both sides. Okay, so if I try to plug it back in, all that I'm not allowed to plug in would be a plus or minus 1. So if we're confident in our answers and our algebra, this is not a positive or negative 1. So we're going to go ahead and assume that those will both work. Okay? So now all of these, I think we might actually just go ahead and cut this stuff, which I can't imagine you'll be too upset about. We might look at some of these story type problems in class, but I think that this is probably about good enough for now.